Oh, sitting in the basement because kids are crazy. I'm going to start recording now so I don't forget to record later like a moron. But you guys were all here, so you're okay. Apparently, there's. Oh, we just populated. We went from 4 to 7. I have a. I get currently in the meeting, and it's a number, and it's like, oh, there's all sorts of people, but then I realize one of them is me. I don't count. But we'll wait a minute or two. I won't mess up today. Well, I can't now. I've already started. Hmm? Oh, your keys. To what? You can't go anywhere. Mm, okay. Hi, Kathleen and Simon and Caitlin and Sarah and Emma and Ava, who are always usually quiet. If you don't like to talk, there's always this chat window over here. Just because there's no reason not to. I'm gonna have to eventually. I'm gonna close Firefox so I don't have to worry. Um, I don't know what your screen looks like, but I get this little. I can see who's here, and that's what I normally leave it on. And then there's this one over here that's a chat that, like, we did our staff meeting on here yesterday, and there were all sorts of people who talked there. What is going on with somebody's? Was that? Is that Jaden? I don't know who that was. Oh, did you make a phone call? Oh, that's the last thing I want to do is be broadcast around somebody's house. This is awkward enough. Like when I save the videos, it's like, oh, you can play it. And it's like, no, I don't want to hear what I sound like because everyone sounds different than on recording as they do in their own head. So, well, it's Friday. I don't know how long we wait. I don't want to keep you too long. Um, bookkeeping stuff. Yeah, well, yeah, not that it really makes a difference. Um, I put two new things in the files section for next week once it populates. There we go. Chapter 9 is naming. So these are kind of the examples that we'll do. Um, and naming compounds package. This is the one that we talked about on the very first day. There are 10 pages of stuff. Do I expect you to do all of this sitting at home? No. But if you want to, you're more than welcome. Will eventually put answers to all of it up. Um, Unfortunately, things aren't numbered, but um, there's those and the notes. I don't know why it aren't like it's not going to look like it's a whole lot of pages because that chapter is a combination of the two things. But oh, and apparently oh, that's the acids page. So we'll get through as much of that as we can next week. Hopefully, I don't mess everything. I had tried to call into a second meeting this morning. I totally messed stuff up. Oh, Haley's there. How are Haley's new puppies? I don't know if I'm in my basement because Kate is still awake, and that's to say Ben wanted to play in the living room this morning and he's not quiet. So I said, I'll go down in the basement. It's quieter, it's cooler, and whatnot. Did all of you see the pictures of Haley's mother's? I don't know if they're hers or her mother's new puppies. Their dog had like 10 puppies.
They're definitely mine, and they're really whiny.
Well, they're so they're Haley's now. The question is, if you sell them, does Haley get to keep the money or?
Um, really? We're splitting it.
Okay, well, we've got 11 of you here. That's a third. But I can imagine a house with 10 new puppies is probably not all that spectacular. It probably is loud, and I don't need that right now. Uh, so if you are just getting here, check the files page for new notes. I'll post something in there and say that's what we're going to look at next week. Today, I just want to go through. Um, if you missed yesterday, because I was a moron and forgot to click the record button, that's why there's no video. The notes are there. We talked about shape, and there was a link that I had to a web page that you can visualize these a little better. And what we're going to do today, you're technically in Chemistry 11. I simplify the shapes: tetrahedral, pyramidal, bent, oh no, linear, the two types of linear, whether it's two atoms or three atoms, or technically four, trigonal planar, and there's two types of that. We talked about, we're going to go through those shapes and talk about polarity. We talked about bond polarity, which is straight a difference in electronegativity. If you have a small difference, it's nonpolar. If you have a big difference, it's polar, and it's just about a separation of electrons. It's like a tug of war. And molecular symmetry, um, polar has to have, if it's got lone pairs, it's going to be polar. If it has no lone pairs, that's the iffy part. If it's, which really means linear, trigonal planar, or tetrahedral. If everything is the same around one of those shapes, it's nonpolar. If one thing is different, it's polar. So, oh, well, we'll start here. So use whoa, VSEPR to do, I think I said A, B, D, and F because, well, we talked about SO3. I can draw it and we can talk about the shape. CO is an easy one to figure out the shape. So I'm going to just quickly look at, whoa, C. Okay, we're going to do this. SO3, if because it's earlier in the notes. Oh gosh, even in the basement with these big headphones, I can hear them upstairs doing. Oh, that was a thud and an ow. I'm glad I'm downstairs and it's not my fault. SO3 looks like this. Are there any lone pairs around the sulfur in the middle? No. So this has no lone pairs. So if I go back to uh, this page, I have three bonds, no lone pairs. So SO3 is trigonal planar. Carbon monoxide is looks like this kind of. For our purposes, that's good enough. Actually, that's the only way to draw that. 4 and 6 are 10. 2, 4, 6, 8, 10. If it's got two elements, Two atoms in the molecule. What shape is it? Yep, it's linear. Anything with two atoms is always going to be linear. It's nice and simple. When we talk about polarity, this is trigonal planar. So this could be polar, it could be nonpolar. Is everything around this the same?
No.
Oh, okay, I need to rephrase that because technically that oxygen looks a little different than that one and that one. But when we talk about things around it, those are all three of those are oxygen, right? So because everything around is the same, therefore this one is nonpolar because when we drew this, we could move the double bond from here over to here. We could move it over to there. So actually that's the actual molecule is an aggregate of the three that we talked about last week. If it's linear and those elements are different, this technically has to be polar. This, I got to do it, is a really interesting molecule because carbon monoxide, uh, it's mainly made through incomplete combustion. Like your car will have a little bit of it. Technically, I think we might breathe out a little bit of it. Carbon monoxide is polar. There's no doubt that it is polar, but which end is the positive end and which end is the negative end has been a discussion in chemistry for 40, 50, 60 years. And I mean, when I was in university, I read one paper that went through all sorts, and half of the study said carbon is the positive end and oxygen is negative, and the other half said vice versa. So I think we've done some of these. We drew carbon dioxide the other day. Carbon dioxide is like this. You can go back and look at it. So carbon dioxide has two kind of bonding sites. Are there lone pairs around the carbon? If it's
No.
so there's no lone pairs around the carbon, that's linear. So these are both linear, but this one is polar because the ends are different. It does this have the same thing on each side?
Yeah.
So if the same thing is on each side, this is nonpolar. I'll do the Lewis structures for those three here in a minute, but I think there may be one sort of like this. Regardless, even if there's like 8 atoms in a row, if it kind of you can split it down the middle and one side is the same as the other, it's going to be nonpolar. B is SiCl4. This has 4 valence electrons. This is 4 times 7 valence electrons. 4 sevens are 28 plus 4 is 32 valence electrons in total. Normally, a lot of the time, most of the time, I'm sorry, chemistry is full of exceptions. Uh, the first element is your central atom. So silicon goes here, chlorine, 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 chlorine. We need to put electrons in. Well, we've got to bond these together. 2, 4, 6, 8. So, well, silicon looks like it's happy. So let's put the rest in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I had a professor in university who did lone pairs like that as dashes, which was really slick, but he wouldn't let you do it in a second year class, but if you had third or fourth year, he would be okay with it. So silicon, chlorine, 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 chlorine in terms of, and this is where why he did it, because this is so unbelievably tedious. Because if I just dot, sometimes it doesn't look right. So there's the Lewis structure in the structural diagram. This has four bonds, zero lone pairs. No, not lone pairs, lone pairs. Therefore, if it's 4 and 0, this is tetrahedral. If it's tetrahedral, it could be nonpolar. Is everything around the silicon the same? Yep. Therefore, this is nonpolar. So far,
How would that work if like because you said it could be either one.
so you have to look at if that wasn't a chlor. I'm going to do this a different way so I don't have to do as much erasing. If I change that to from a chlorine to a hydrogen, they're not all the same. Therefore, it this would be polar with the hydrogen there.
Okay.
So as long as um, whoa, what happened there? Move that over to there. So I've got
What
SCl.
about if silicon had lone pairs with it?
If silicon had lone pairs, anything generally with lone pairs on a central atom for us is going to be polar. There are some cases with some weird molecules, but they're usually more exceptions um, that can be nonpolar. But for our purposes, I think it was SCl2, 2 times 7, 14. So this is 20 valence electrons. Sulfur, whoops, chlorine, chlorine, two in between to stick them together. Fill the outside, 2, 4, 6, 8, 12. So I've got 8 and 8 are 16. Sulfur only has 4. So I have 2 there. So changing those two lines, we do that. And now sulfur. This is different from carbon dioxide. It has two bonds, bonding sites, but it has two lone pairs, one here and one here. If we have that, when you have those lone pairs, this one ends up being bent. Anything that has lone pairs here is going to be polar to some extent. So far, so good.
Yep.
F for French fries. H2SE, you never want to deal with that. If you think a skunk smells bad, H2SE makes a skunk smell good. What? Two?
That's what's in tomato juice.
No, no. Um, oh, I like a skunk. The smell from a skunk is something that has an SH. It's some organic molecule with an S. Selenium is one below. It's not that it's is always the case, but for sulfur, selenium, nitrogen, phosphorus, um, the further you go down in those couple of groups, the worse the smells are. One guy that I worked for in university, he said years prior, there was a guy who actually had to use that for a time being, and he could only use it in the evenings and on weekends because he had to basically, even though he was doing everything that it was all sealed and there's different ways because that's a gas. Um, he couldn't do it during regular hours because it smelled so bad. So there's 2, 4. Selenium isn't happy. So this is H. I almost put a capital, which would have been awful. So sometimes I will inherently, if I know, well, what the shape of something is, which any of these things I have some idea, um, I draw them slightly. This one, even though this is hydrogen and that one's chlorine, it's still that situation and is bent and polar. Sorry about the slurp. Oh no. So the one other thing I kind of want to look at some of these. We've done a handful. Uh, so we've drawn some of these, like we've done those structures. So I'm not going to skip the Lewis structures of that. Actually, I think we've done a bunch of these. Uh, so that might kind of be, we'll talk about HF. Well, the only way to draw HF is like this. What shape is a diatomic molecule? This shape always is going to be
Linear.
linear.
If you had like three elements, like say if you had like HF, I don't know, like O2 or something, could, or like HFO, could that be linear?
Uh, yes. And there's one that we'll go back to that in a sec. Once we, I just want to polarity. HF, are those the same? No. So if we go back, Matt asked a good question. Like we've talked about, and I'm going to just water. If we draw water, which we did, like that was one of our first Lewis structures. Sometimes I even draw water like that, which again, I can't show you why because we're stuck in our own houses. Um, it has lone pairs, so this is bent. If it's got lone pairs, so we did way back, um, closer to the beginning. What are the odds I hit the page right on the nose? Hmm, close. We did way back here, HCN, and I'm gonna, and then we did somewhere here, HNO. So these are ones that we've done, and I'm just gonna rewrite them back with water and whatnot, so we can compare. Whoop, here we go. So we did HCN. No, you're teaching. Don't look at your phone. H. So those both have 3 elements, just like carbon dioxide. But this is I think where Matt was going. because these are three different elements. Are there lone pairs on the carbon?
No.
Nope. So if there's no lone pairs on the central atom, that one's going to be linear. Are there lone pairs on the central atom? There's a lone pair here, so that's going to be bent. And because now both of these, it's linear, is hydrogen different from nitrogen? Is hydrogen different from nitrogen? Yeah, so that's polar. Is hydrogen different from oxygen? Again, yes. And that's polar as well. So there's different variations, but it's really about, are those the same or are they, and the carbon dioxide was the other one that we talked about a second ago. This is linear because there's no lone pairs, but because the oxygens are the same, nonpolar. And then we did ammonia, which again is back in your notes, which is why I'm not going to waste time and redo it. This has three bonds. If it's got three bonds and one lone pair, this one is pyramidal or trigonal pyramidal. Are there lone pairs? Yep. So this is polar. Oh, and this is the one. If you have ammonia, a lot of you will have this in your house. It's a cleaner. It smells like it has a strong smell. It's not awful, but it has a fairly strong smell. If you replace that with phosphorus, oh my lord, and you had a drop of it, you could like clear out a room or worse. If you had arsenic, well, I think the arsenic one is toxic. So we've done those. So we have these two to compare, which I think we talked about CCl4. I'm just going to redraw them in terms of CCl4 is like CH3. Wait, crap. Is CCl4 on your assignment? You can be honest. I just don't want to look. The first question is something like that. Whatever. If it is, it is. It's go away. So CCl4, carbon tet. The first lab I worked in after my third year, I've got dirt on my screen that looks like an electron. So I had to wipe it off. CCl4, um, it's kind of neat. It's there's no lone pairs. So this is well, it's tetrahedral. Any generally speaking, any carbon with four bonds, one, two, three, four bonding sites is going to be tetrahedral. Everything is the same. That's nonpolar. Was it H3Cl? Oh, yeah. C. This one actually, of the chlorinated carbon compounds, is the least common. Uh, this is, again, tetrahedral, but no, that's wrong. This is polar because that one chlorine is different from the rest. If there's one thing that's different, it's polar. Carbon tetrachloride is like if you had a bottle of it and picked it up, it is, oh no, oh, sorry, funny bone. My whole arm tingles now. You pick up a bottle of water. It had like you know the mass that you expect it to have. You know if it's a 500 milliliter bottle of water, what it's going to be. Carbon tetrachloride weighs has a significantly higher density, so picking up a bottle of it like weighs twice as much as you would expect, which is kind of neat. But it why it was so useful is it boiled at a much higher temperature. It boils at some over 200 degrees, I think. Something in a classroom I would look up, but whatever. I know it's higher than 100. Um, it's nonpolar and has a high boiling point, so it was great and it was used for years. Then people started doing research on cancer and figuring out things like that. And it's like, oh, this stuff is awful. So I think when I was in my third year, we had a bottle that we had, I don't know, 300 or 400 milliliters of it. And it was the only place in the building that had any of it because you can't buy it or you couldn't buy it at the time. So that's kind of what we need to do. These are, oh, I did apparently H2S at one point. It's polar and very stinky. Ironically, Ni3 is in like a purple ink. Is Ni3 is actually purple. I did the same things again. That's what we just did. I'm going to, when I post these later, I'm going to put these in here because there's two slides. If we had a test, there's the review questions for your test, but you don't have a test, so I'll put them up there. Some of you might want to take a look at them. Those two slides are on intermolecular forces, which I think, oh, I closed it, is the back half of that chapter. Um, if you've heard the phrase like dissolves like, that has something to do with it. It's how things stick together. Why is this taking forever? Buzz off. I don't want to keep you guys all day, so be nice to me, computer. Bond energies, resonance, octet rule. Like there's all sorts of good stuff in here. Bonding theories you don't have to do. Hybrid orbitals. Ah, 8.4 is about polar bonds and molecules. And in there, oh, this last little bit attraction between molecules, it tells us the stronger these attractions between things, the more solid they tend to be. And there's little bits there. You can read it, um, but I'm not going to spend much more time other than molecules are attracted to each other. Ionics are nice. They're ionic. What's the word? Electrostatic interactions. They're all technically electrostatic, but I'll let you, if you have questions, you can do that. But other than that, that's kind of all I had. Um, I think I switched the assignment to be due next Friday. Have any of you got a document or your parents got a document from the district about credit versus no credit or credit, sorry, versus enrolled because that's a different situation. There's supposed to be one coming today. I don't know when parents are going to get them. Oh, okay. So apparently in that, like, grade 11 and 12 is the only one that this whole situation really stinks for. If you're in grade 9, well, there's no real credits, but you guys want this course for a transcript for some colleges look for chemistry 11. Some colleges or universities are going to look at all sorts of things and what is there, whether it says credit or enrolled, is a dependent thing. I talked about it a little bit this morning with math. And if you're, and I made a form for pre-calc. I'll probably do one for this as well. Um, but It's from my understanding, a lot of it is at my discretion. I'm not going to be assigning anything that I'm going to formally mark and say, oh, well, that assignment that's up there says, oh my gosh, it's out of 20. Well, if you attempt it and get at least most of the structures drawn properly, I'm going to say, okay, good, check, carry on. Um, and some of you are going to be able to not do anything, absorb this material, and go on to chemistry 12 and not have any issues. But it just depends on if you want that or not. But it's when we do naming, I'm going to probably put a couple things up where name and write the formula for these 10 things and submit it. And if you get most of them good, I'll give you some feedback and say, well, this one or this one might not necessarily be right. And if you do enough of that, I'm going to say, okay, good. We can put credit next to their name on their transcript. But if you're just going to sit and watch and aren't worried about it, that's great. Um, it's kind of up to you in that sense. I'm not going to force anybody. Uh, my goal is to pass on some of the information that you're going to need for next year. So I'll try to put that form up later this afternoon or this weekend. It's not, but I don't think it's technically a rush. You don't have to tell me by next Thursday, do I want to do the work for a credit or not? You can start and then stop. You can stop and say, like, there's a due date for that assignment. Well, if you decide to do it 3 weeks from now and submit it, I'm not marking it. So, okay, well, if you did it 3 weeks from now and you still did it, well, okay. It's about checking boxes more than um, putting numbers down. So I would get like take a look at that document that came out with your parents and discuss if there's specific questions. I can try to answer them, but Mrs. Lauritsen or Mrs. Meehan may be a little bit of a better source of information. But my goal is to try to get you guys to know as much as we can. So I don't want to keep you any longer than this. I may just for I've heard some people are doing 3 classes a week. I don't know if people want to stick with trying to do half an hour a day or do something maybe a little bit longer, 3 times a week or 4 times a week. I'm not sure what people's thoughts are.
Yeah, I'd rather do it.
Yeah, we shouldn't do it every day.
Oh,
As it's like the hour, like the PhD or whatever.
yeah. And if that works for everybody, yeah, I'll like even if we go to like 3 times a week, I'll still record stuff um, so people can go through and make sure they know what they're doing and whatnot. So,
No, like Wednesday's like a day off.
or do Monday to Thursday and not do Friday. We'll talk about that as we go on. I'm gonna leave it scheduled um, for next week, but I'll be here Monday for sure. And then like when we do naming, it's like I can go through the stuff and if we don't do it, like if we go through ionic compounds on Monday, we can wait and you can work and we can pick it up on Wednesday. But we'll see. I mean, again, it's all just kind of playing it by ear and whatever works for you guys is that's kind of my goal. Now there's talk about potentially in a couple weeks relaxing things. So if our babysitter starts taking kids, well then I'd be available more. And if one group of people wanted to do something in the morning and versus the afternoon, I can always start to do that. But we'll cross that bridge when we get there. But unless there's any other questions, I'll let you guys go.
Who
And
sent you the picture of our work?
oh, that's a good question. I know, like, I've I've got some from a couple people in another in pre-calc. Um, I don't know. How I will have to double check on that, but there's some way that you can upload files in here. Like when you go into your student view, um, there's something in this student view that you can upload because I can, I mean, for,
Just like copy it onto another Word document and then just glue it on that and send that to her.
well, you could do that way. You could do it on paper and just take pictures with your phone. And there is a way to upload it. I'll look into that. And if someone has issues with getting it to me, worst case, you can take pictures and email it. But if we can get it in through here, that would be the best way. I'll double check on that this weekend and try to get back to you guys on Monday. Sound good?
Yep.
Have a good weekend. Stay safe. Thank you. Don't do anything foolish. Not that there's much to do. Adios. See you later.
Okay.
Bye.